Good afternoon to each and everyone. I am here to present the topic given by Mr. Joao Pitogo, which is the ANOVA two-way classification. ANOVA for two-way classification. The two-way analysis of variance incorporates two independent variables in the same analysis, thus allowing more powerful tests of differences among means. In these two independent variables, research design, one of the independent variable is set up in columns and others in rows to form a block of cells. A cell is a combination of treatment conditions that is unique to one group of subject or where a row intersects a column. The solution and formulas for the two-way analysis of variance are as follows. Step 1. Determine the null and alternative hypothesis. Step 2. Find the total sum of squares. Step 3. Find the columns of sum of squares. Step 4. Find the row sum of squares. Step 5. Find the interaction sum of squares. Step 6. Find the within sum of squares. Step 7. Compute for the degrees of freedom. Here it shows the degrees of freedom, which is the rows, columns interaction within and total. For the formula of rows is 1 is equal to the quantity of R minus 1. For the columns is 1 is equal to the quantity of C minus 1. Interaction 1 is equal to the quantity of R minus 1 times the quantity of C minus 1 within is equal to the quantity of N minus R of C. Total 1 is equal to the quantity of N minus 1. Step 8. Find the variance estimate or mean squares. Step 9. Find the F ratio and complete the two-way of ANOVA test. It shows here the formula of F ratio. Example 8.2. A researcher wants to determine the effect of a new teaching methodology for elementary mathematics. She believes that proficiency of the grades for pupils under the new methodology may be related to the pupil's prior achievement in conventional elementary mathematics and their tendency to persevere in past study pattern. A research consultant designs a one grading period investigation in which the dependent variable is the achievement in elementary mathematics as measured by a specially designed achievement test. The grade 3 mathematics level of achievement of the sample subject is designated as the first independent variable. Based on this prior level of achievement, grade 4 pupils who will be using the new methodology are classified as high achievers, average achievers, and low achievers. The second independent variable is designated as pupil's tendency to persevere in prior routine, as measured by a rigidity test given to all students in the subject. According to their test scores, the subjects were divided into three groups designated high rigidity, average rigidity, and low rigidity. Using a two-way ANOVA test, significant differences exist between the given variable use 5% level of significance. Null hypothesis, there will be no. Null hypothesis 1. Difference among the three achievement population in the mean performances in the mathematics elementary achievement test. Null hypothesis 2. Difference among the three rigidity populations in their mean performances in the elementary mathematics achievement test. Null hypothesis 3. Interaction between student membership in both independent variable population and their mean performance on the elementary mathematics achievement test. Alternative hypothesis, there will be difference among the three achievement population in the mean performances in the mathematics elementary achievement test. Alternative hypothesis, difference among the three rigidity population in their mean performances in the elementary mathematics achievement test. Interaction between student membership in both independent variable population and their mean performance in the elementary mathematics achievement test. It shows here the computation table prior elementary science achievement. Rigidity tendency, which is the high tendency and the subtotal. Low achievers, average achievers, high achievers, and the total. In the first column, rigidity tendency, it shows here the high tendency, average rigidity, and low rigidity. Total sum of squares. It shows here the formula on how to get the SS or sum of squares. Sum of squares is equal to 760 minus quantity of 1426 squared over 27. The total sum of squares is equal to 1446.07. Column sum of squares is equal to the quantity of 412 squared over 9 plus the quantity of 474 squared over 9 plus the quantity of 540 squared over 9 minus the quantity of 1426 squared over 27. The result of column sum of square is equal to 910.51. Total in this table, they get the 1426 here. So the total and overall total on this table. So row sum of squares, so is equal to the quantity of 437 squared over 9 plus the quantity of 470 squared over 9, 519 squared over 9 minus the total, the rigidity tendency total, which is the 426 squared over 27. So the result of row sum of square is equal to 378.29. Interaction sum of squares. A subgroup SS is equal to the quantity of 119 squared over 3 plus the quantity of 148 squared over 3 plus the quantity of 170 squared over 3 plus the quantity of 157 squared over 3 plus the quantity of 175 squared over 3 plus the quantity of 155 squared over 3 plus the quantity of 119 squared over 3 plus the quantity of 195 squared over 3 and the 1426 squared over 27. Subgroup SS is equal to 1317.38 and the interaction SS is 28.58. Within sum of squares, SSW is equal to 1446.07 is equal to the quantity of 378.29 plus 910.51 plus 28.58 is equal to 128.69. So the degrees of freedom, so for rows is equal to 3 minus 1 is equal to 2. columns is equal to 3 minus 1 is equal to 2. Interaction is equal to the quantity of 3 minus 1 times the quantity of 3 minus 1 is equal to 4. Within is 27 is minus 33. The quantity times 3 is equal to 18. And the total is 27 minus 1 is equal to 26. In addition, Miss Angela's Resurrection will give an example on how to compute a problem while using the ANOVA two-way classification.
ANOVA for two-way classification. It is classified according to factor or to criteria. Let's take an example of two-way classification of ANOVA. This is the example. We're having four squares which are A, B, C, and D. We are observing their certain days introduced, which is the months April, May, and June. Example of this month is here A, 3, 6, 9. Then the B is 4, 7, 10. C is 5, 8, 11. D, 6, 9, 12. Two-way ANOVA can be applied and the variable can be determined between the column A, B, and C, and between the rows the April, May, and June. So here two independent variables are present between the days, and the seconds is between the month. We will apply between the month the ANOVA to determine the variation between days and the variation between the months. These are two criteria, just like one-way ANOVA. So they are having a table calculate the F value for two-way ANOVA, and the table will be like this. Now, coming to first column, the sum of variation, it will be between the column sum of square denoted by SSC. So then degree of freedom denoted by nu equals C minus 1. Mean of sum of square MSC is equal to SSC divided by C minus 1. Ratio of square between the column MSC divided by MSE. So now coming to second column. Between the rows, sum of square between the rows SSR. Degree of freedom between the rows nu is equal to R minus 1. Mean of sum of square between the rows MSR is equal to SSC divided by R minus 1. Ratio of F between the rows MSR divided by MSE. Then residual of error. Sum of square residual of error is SSE. Degree of freedom nu is equal to C minus 1 times R minus 1. Mean of sum of square residual of error MSE is equal to SSE divided by C minus 1 times R minus 1. Sum of square is total. So the ratio of R between the noted by MSE, total of square SST, then degree of freedom total, nu is equal to N minus 1. Now coming to first steps, which is calculation of grand total and the correction factor. For Ezekiel of this grand total and the correction factor, this case will make made value for this table. So, and we are taking 7 as a made value for Ezekiel. Direction, collection, and the table correction will be like this. So here the A, B, C, and D, the total, then the month, April, May, and June, then total. So 3 minus 7 is equal to minus 4. 6 minus 7 is equal to minus 1. 9 minus 7 is equal to plus 2. Next is 4 minus 7 is equal to minus 3. 7 minus 7 is equal to 0. 10 minus 7 is equal to plus 3. 5 minus 8 5 minus 7 is equal to minus 2. 8 minus 7 is equal to plus 1. 11 minus 7 is equal to plus 4. 6 minus 7 is equal to minus 1. 9 minus 7 is equal to plus 2. And the 12 minus 7 is equal to plus 5. Then 4 minus 4 plus minus 3 plus minus 2 plus 1 minus 1 is equal to minus 10. Minus 1 plus 0 plus 1 plus 2 is equal to plus 2. Plus 2 plus 3 plus 4 plus 5 is equal to 14. 1, then the total of month A and G, April, May, and June. The 1 minus 4, minus 4 plus minus 3 minus 1 plus 2 is equal to minus 3. Minus 3, 0 plus 3 is equal to 0. Minus 2 plus 1 plus 4 is equal to plus 3. Minus 1 plus 2 plus 5 is equal to plus 6. So the total is minus 3 plus 0 plus 3 plus 6 is equal to 6. So this is the grand total. Now coming to the correction factor. Correction factor is equal to t squared divided by n. So the grand total is 6 squared over the whole, which is the 1 2 3 4, so 4, then 1 2 3, so 3, so 4 and 3 is equal to 12. So 6 times 6 is equal to 36, by 12 is equal to 3. Now coming to the second steps of two-way ANOVA, and the second step is calculation of SSC, which is calculation of sum of square between the column. So this calculated by squaring column total divided by number adjorsons minus the correction factor. So SSC is equal to A squared minus NA plus B squared minus NB plus C squared minus NC plus D squared minus ND minus the correction factor, which is T squared minus N. So it's equal to NA squared is 3 minus 3 squared plus B squared 0 squared plus over 3 here over 3 plus 3 squared minus 3 plus 6 over 3 6 squared rather over 3 minus the correction factor is 3. So here, so 3 minus 3 squared over 3 is equal to 3. 0 times 0 over 3 is equal to 0. 3 times 3 squared over 3 is equal to 3. 6 times 6, 36 over 3 divided by 3 is equal to 12 minus 3. So the SSE is now coming to the third steps, which is calculation of SSR, or sum of square between the rows. So HSR is equal to A squared over NA plus M squared over NN plus J squared over NA minus the correction factor, the T squared over N. So equivalent of A squared is equal to here minus 10 squared over 4. What A, which is A, B, C, and D. 1, 2, 3, 4. So minus plus 2 squared over 4 plus 14 over 4 is equal to 3. 10 minus 10, 10 times 10 is equal to 100 over 4 is equal to 25. 2 times 2 divided by 4 is equal to 1 plus 14 times 14 divided by 4 is equal to 49 minus 3, the total of 72. Now coming to the fourth steps, which is calculation of SST, or total sum of square. SST, or total sum of square, calculated by all this value here. All this value. So 4 minus squared plus 1 minus squared plus 2 minus squared plus minus 3 squared plus 0 squared plus 3 squared plus minus 2 squared plus minus 1 squared plus 4 squared plus minus 1 here squared plus 2 squared plus 5 squared minus the correction factor is 3. So total 4 minus 4 times 4 is equal to 16. 1 minus 1 1 plus 2 minus 2 2 times 2 is equal to 4. Minus 3 times minus 3 is equal to 9. 0 times 0 is equal to 0. 3 times 3 is equal to 9. 2 minus 2 is equal to 4. 1 minus 1 is equal to 1. 4 times 4 is equal to 16. Plus 1 times 1 is equal to 1. 2 minus 2 times 2 is equal to 4. 5 times 5 is equal to 25 minus 3. So the total of 90 minus 3, then total of sum of square is 87. Now coming to 5 steps, which is the calculation of SSE, or the total sum of square due to error. So SSE is equal to SST minus SSE SSC plus SSR. So the total of SST is equal to 87 minus the total of SSC is equal to 15. So the total of SSR is equal to 72. Then 87, 15 plus 72 is equal to 87. So the SSE is 0. So this is the F value for the grand total. New 1 is equal to 6 and the new 2 is equal to 3. F 0.05 is equal to 4.76. Then F value for the seconds is new 1 is equal to 6 and new 2 is equal to 2. And F 0.5 is equal to 5.14. So this is the tabulated F value. Is the all table of Toei ANOVA. Sum of variation between the column, between the rows, and residual of error. Sum of square of between the column is SC as 15. Degree of freedom new to is equal to 4 minus 1, which is the A, B, C, D, and D is 1 minus is equal to 3. MSC is equals SSC over C minus 1 is equal to, which is this is SC 15. Then over 3 it is equal to 5. Next is SSR is equal to 72. Then new 2 R minus 1 here 1, 2, 3. 3 minus 1 is equal to 2. MSR is equal to SSC over R minus 1. 72 minus 2 over 2 is equal to 36. So next is SST. Equivalent SST is equal to 87. Then degree of freedom total is new 2n minus 1 is equal to all over the this table is equal to 12 minus 1 is equal to 11. So residual of error SSE is equal to 0. Then degree of freedom new to C minus 1 R minus 1 is equal to 4 minus 1. 3 minus 1 is equal to 6. MSE is equal to SSE over C minus 1 times R minus 1. Here MSE SSE 0. Then the equivalent of C minus 1 into C minus R minus 1 is equal to 6 is equal to 0. So this is the ratio of F MSC rather over MSE 5. Here 5 is equal to 0. MSE here 0 is infinite. And here this is getting infinite. Some number we will use here. We calculated the F value, so the total F value and calculated values of 4.76. So here different significance between the days, which is A, B, C, and D. So MSR over MSE is equal to here 36. MSE is 0, so infinite. So calculated value infinite in the table value of 5.14. So calculated value greater than the table of value, it means very significant difference among the month, which is the April, May, and June. So we can conclude the significant variation between days and month, between the days and between the month. So this is complete the detailable steps of Toei ANOVA. That's all. Thank you.